Welcome to LibreQuest. My name is Matt, and this is episode 49. I had a listener request for the return of Imam to cover game development on Linux. Hello, Imam. How are you?
I'm good. How are you, Matt?
Oh, I'm doing good. So, can you tell me about what kinds of tools you personally use for developing games on Linux?
So this is a kind of big topic. We cannot um, uh, talk. We cannot make it like a really short. So Linux is a different world. You have to just like a console game development. You have to think about when you're coming from a different platform like Windows. You have to think about what are the tools or what are the advantages of developing games. Uh, what I understand, we're gonna talk about today Linux game development, right?
Yeah.
Developing game. So there is two things in this area. One is developing game inside Linux using Linux as a platform, game development, and the other one is uh, developing game specifically for Linux. Linux is the target platform, right? So I'm gonna cover both a little bit. One thing is Linux development. So with game development, you have to understand if you're already a game developer, you already know what are the tools you need, right, to develop a game. You need a game engine, you need productivity modeling suite, 3D, any programs helps with the creation of the contents for your game, right? It could be a 3D modeler, and you need a game engine. You need a stable graphics stack, and all this stuff um, is available on Linux, just like Windows. But the thing is, they are slightly different. So you have to be aware, make yourself aware about the differences between Windows and Linux game development or Mac. Um, Hello?
Yeah. No. Go ahead. I was just listening. Yeah, I understand
And
I understand what you're
it's,
saying. So you're
uh,
talking you're
feel
talking
free
about
to feel
yeah.
free to interrupt, man. I don't have to be like talking. You can anytime interrupt me.
Okay,
I'll just
no. I was listening. I wasn't sure exactly where all you were going with that, but I understand you're kind of differentiating between somebody who's targeting Linux specifically or Linux exclusively, and that there's different tools available for that, or different. I guess a different way that you would target that, where you're targeting specifically the graphics stack for Linux, opposed to something that's more compatible with other systems. But if you were going to target just a Linux system, what tools would you use to do that?
First of all, Linux. You have to think about the background of the Linux. Linux is not very unique in a sense that it came from a Unix operating system, and all the tools in Linux is pretty much cross. I would say cross-platform. So cross-platform development tools. Like you think about OpenGL and Vulkan, all of these are available not only on Linux, they're also available on Windows, Mac. So anything you find on Linux, most of the thing we're talking about the graphics stack. We're talking about development tools, whether it's a C compiler, which is GNU, right? But you also use proprietary programming compilers such as Intel one from different vendors. But necessarily all the tools in Linux they are cross-platform. So uh, if you go with the open standards, you can easily use all the development tools. But there is a distinct different the difference of but there is a distinct difference in Linux as well. Uh, One important factor, I think, important thing about developing for Linux and um, is the thing you can target different operating system while you are developing for Linux. It kind of improves your um, how do I say Suppose you're using Linux as the main platform. So what's gonna happen? You're gonna end up using all the cross-platform tools, right? And then your game, by the end of the day, will be cross-platform by default. You don't have to worry much about that. But there is a specific thing you have to be aware of, which is specifically to the Linux. It's not compatible with Mac, and it's not compatible with Windows, which is one area you have to be uh, aware or you have to gain knowledge about, which is the Linux file system, right? A structure, how the Linux file system. If you remember, in Windows we have del file, like shared library, right? .ll, which are the library files. Then you have to on Linux there is a similar library file you have, which is .so file, shared file. So you have to make sure you understand how the shared library files or static library files um, in your what kind of engine you use, whether it's a game engine you're using. You have to understand how this game engine running on top of Linux. So to understand this, you have to understand the library files provided in the Linux.
Yeah,
Do you,
I was just going to
yeah,
say one of my thoughts on that is depending on what distribution you're using, your libraries could be located in one area of your file system structure, or they could be they could be located all over the place, and you've got different libraries that are included in all this stuff. So how would you address that? Like if you were designing for something that's going to be distributable across different distributions, I mean, would you go something like app image or some kind of containerized installation? Or I mean, I'm not really familiar with the game development myself. That's why I'm asking.
Nowadays, you can get off-the-shelf game engines like Unreal, Unity, right? They will take care of most of the stuff, so you don't have to worry about. But I still feel you still need to understand how the C programming works because Linux is built on top of C. Everything in Linux is C, basically C and C++. So if you are facing your game is crashing or it's having problem, your engine or whatever, so you have to understand how the Linux library files and then C program, how to debug your C program. So there are various tools to debug your C program, right? Like GDB, GNU debugger, and then to find out the memory leak, like if there's a memory leak in your program, then you can use Bulgarian. So you have to get familiar with the Linux way of you have to focus in the how the C programs works inside Linux and also the shared files. Yeah, you're right. The shared files are one of the how you're gonna distribute them, right? One of the challenge is the same as one of the main factor I think most important is how you compile your shared library in which distribution, say which version of a standard C library. If you are distributing very recent one, then it's not gonna be compatible across different distributions, right? So you have to because Linux oftentimes they come up with this recent version of GCC or JNUC compiler, which is not compatible, and with many other distribution or even on Windows, it's not available because it's too recent. The specification of this new C standard is not available across different platforms. So you have to be careful, specifically which C version or C++ standard you're choosing for your compiling your game engine, or whether it's your game engine or it's the main program game file.
Yeah,
You have
just
to be aware.
oh,
Yeah.
I was just gonna say, like in my experience, even like using a game that is currently being maintained that might like an open source game or a free software game. Like even sometimes using those, there's parts that are broken, there's parts that don't work, and depending on what distribution I'm running it on, I might have to go track down a specific file and see what's going on in the background, and then move that to where the game is actually looking for it. So that was kind of my thing. Like in my experience in installing some of the older titles that were ported to Linux, you had to do the same thing. You might be looking for libgl, and you might have to go into your library and then move that into the directory for the game and stuff to even be able to launch it. And that's just kind of my thought. Like it seems like it'd be kind of difficult. It's a little bit difficult unless there's some sort of like contained system that you can distribute. So I was wondering how would you address that? Because you might not know what files you need to include, right? Depending on the distribution that someone's using.
Yeah, uh, we already have a solution for this, like a traditional old traditional solution. Like you put the shared library file in the same folder where the executable file is, game executable.
Okay.
So you don't give it a fixed location or a fixed directory location. You make it like a volatile address. The address has to be volatile, so it will pick up the current directory as the uh, shared library linking address.
Okay.
So once, like just like in Windows, when you have a missing Microsoft, what is it, C++ library file, you just download that specific file and put into your game folder, right? And it works. You don't have to install the same file system wide,
Right.
copy that for all. Then you have different version of the same library, right? You can overcome all this just simply by making the library file or whatever it is be like a volatile. Like it doesn't have to be. What the most distributions do when they compile this shared library file, that's the main problem. They give it like a hard fixed address, right? And it's only can be changed during the compile time when you building the library, right? But when you're compiling the library, you can also give it not any particular fixed address. So what happens in that case, you can put it anywhere and it will just look into the current folder.
Okay. Yeah, because I've seen that in installers before. It's like, hey, can you tell me tell me where this file is located? And you're like, I don't know. Let me look for it.
For LDD command on the executable file, it will tell you what libraries are missing for this particular executable, right?
Yeah.
And you see all the time it will say, okay, it's looking for a particular folder for that file, but the file is there, but not in the same folder it's looking.
Right.
So this is the problem, right?
So how does that work? Is it because I don't, like I said, I don't do any game development or anything. Is there some sort of a manifest file or something that it checks to for dependencies to actually let a user know what it needs? Because I'm not sure. Does that something you just make a list in there, or how does
There's
that work?
there's a LDconfig file, but that's for system wide. But my understanding and solution is just like in Windows, you don't get, when you're compiling the library, right? When the devs or game developer, because pretty much these standard C library files, they are open source, right? Most of the library files that comes with Linux, right? They are open source, so you don't have to use the one distro provided by the distro. So you compile your own library file, whichever needed for your game before you distribute it. But for the while you're developing, you can use the distro provided one. But when you're going to distribute it, I think you just compile the particular library file for your game specifically, and you don't give it a fixed address.
So
Normally, what happens? Yeah.
no, go ahead. Go ahead.
Normally, what happens? These library files they are searched through the lookup table stored in the LDconfig file, right? So every time you add a new library to your system folder, you basically update this LDconfig file by invoking the LDconf command. But that's for system wide. But for games, they don't need to be system wide. they can be portable or self-contained in a folder, just like in Windows any game nowadays. Just like how the Steam is doing with their game library.
Okay.
So
Okay. So you're saying
yeah,
like kind of how Windows would have like a I don't know what they're using today, but a DLL or INI file that might need to be included with the game, they could just include that in the install directory.
yeah,
Is that how
and
that works?
that's how it works. But you have to make sure you compile that library in a specific version of GCC, which is not very recent. If it's too recent or if it's too old, so you have to pick a. You have to be careful which version you pick, so
Oh
that
man.
it's not yeah, it's compatible across or even in the coming time 10 years. Because I still have some old games. They don't. Some of them runs quite well without changing much, fiddling with the library files, right? So, but some of them are not compatible anymore because of this library problems.
Yeah, so you're saying that even if you do include it and it's maybe in the local directory structure, that it may not be
Yeah.
compatible with other parts of the system.
Reason is even if you compile the C library on Linux, uh, on Linux there is a problem. C, the main C library and the kernel they're very close. Like if you change one, the other one has to be changed as well. So
Okay.
what happens? That's why it's really hard to change the system C library. Basically, so you have to make sure you pick not when you write a program, it only uses cross-platform or um, C functions or the functions which are available and not very recent. Or if it's recent, you have to make sure it works across various specifications. It doesn't break. So you can test it with a very old distro and a very new distro. If it works in both, then it's good to go.
Nice. Yeah, so that's a cross distribution game, right? At that point.
And then you can test it on Windows too with the GCC library. So it's easy. And the other thing, yeah.
So is that
And
no, go ahead.
no, you said.
Oh, no, I was just wondering is it easier to develop like if you're developing a game, would it be easier to be working from a Linux distribution and targeting other operating systems easier than it would be if you were developing on a Windows machine or a Mac, or is it kind of irrelevant when it comes to programming? I'm on it for programming games specifically. I'm not really sure.
Uh, I'm familiar with both system Windows and Linux. And in the I'm pretty familiar with the development in both systems. What happens when you develop for Linux? Basically, um, you're benchmarking. Your code is you creating a clean code. What I mean by clean code, because on Windows there are APIs and libraries that are not well documented and they don't follow on a specific standard, right? So what happens if it's working on Windows, it would not work with other platforms easily. But if you're targeting for Linux, there are several advantages. One thing is it would work on Windows most likely, and also Mac. The reason is on Linux, if you're not using very Linux specific libraries like Pulse Audio for audio, if you're sticking with the cross-platform library, then it's gonna work across it's gonna break on different Linux distribution, but it's not gonna break for Windows or Mac. And also, your code is gonna be very robust, and the binary is gonna be end up, and you can also do the cross-platform development on Linux. Very It's not very hard with libraries and tools available.
Well, I've noticed a
I,
lot. Oh, sorry. Go ahead.
yeah,
Oh, okay. Well, I was just gonna say I've noticed a lot of titles, like at least using Steam Proton. A lot of titles will outperform a native ported game if you run the Windows version and use the Proton compatibility layer to run it. And I assume that's because it's using Vulkan, not necessarily because the port isn't sufficient. It's just that they're using OpenGL rather than Vulkan. So, kind of, I guess my question is: do you think that we'll see, at least for native Linux titles, that we'll see more target towards Vulkan over OpenGL in the future?
I think you said something. Yeah, it has some relevance. Yes, of course. But you just reminded me something.
Yeah.
Sorry, I have to avoid your question first, then
No, it's
I
okay. Go
was
ahead.
coming to. First of all, yeah, I don't know if you noticed ever. Sometimes the native Linux version of the game is running slower than if you run the game in a Windows version through Wine, right?
Yeah.
And if the game has OpenGL renderer, then you wonder why the native Linux version is slower than Windows version. I would say this has to do with Windows compiler stack and many other things. Or it could be Windows has many, the drivers has many, I would not say Windows drivers. Windows, the layer of the Windows maybe is not heavy compared to the Linux C layer, right? So when you run the game through Wine, so it's running faster than the native version. So
No, go ahead.
yeah.
Sorry, I didn't. No, I'm not. I didn't mean to interrupt. I was just. Yeah, go ahead. Go ahead. Sorry.
Did you ever notice? I don't know if you have noticed that ever. Certain games I have noticed. If it's the one, say it has a OpenGL renderer, this game, and you're running this game, it works beautifully on Wine inside Wine, and then can you have the native version as well? And the native version is actually not performing as good as Windows version through Wine.
Yeah, no, I've noticed that. There's several games I can think of. Dying Light is one. If you run the Windows version and use Proton on Steam, it outperforms the native version. The same with the Saints Row games, and even Urban Terror, which is I think I think that I think that was first released in 1998. But the newer versions, and I think they're actually getting ready to release Urban Terror 5 now, but which is, I think it's going to be on the Quake 4 engine. But yeah, if you run the Windows version and if you run it through Proton, it way outperforms the Linux binary, like by quite a bit.
The Windows version is heavily optimized. So when you're running Windows version through Wine, so you're running an optimized executable file compared to poorly ported game uh, like a Linux version, which is like they did a really quick job. They didn't spend a lot of time debugging this executable file, specifically taking advantage of different flags available to GCC, right? So when you compile your program, that's what I was talking about. Windows got a different compiler, which is a Microsoft compiler, right? C compiler, and then on Linux you have GCC compiler. So both compiler has their own advantages and unique features. When you compile the file, you can choose particular features you want to enable through different flags, compiler flags. So is essentially it's one executable file is better optimized for the CPU than the other. I can give you one example. When I run PS2 emulator, right, through Wine Windows version, it runs actually better than the native PS2 emulator.
Oh wow,
I get
huh.
yeah,
Yeah, I never tried that.
it's a yeah, sorry, yeah, but then I figured out why the native version. I mean, essentially both of them fine. Both of them using OpenGL and everything is fine. Later, I found out when I updated my kernel with low latency kernel, the native Linux version is catching up, but it's still not the same as a Wine version. So essentially, it's the compiler optimization. That's another area. If you're a game developer, you have to be aware of what kind of optimization you can apply to your executable file from Linux.
Well, do you think that that might be like an area of focus for developers to really focus on creating something that's going to be a little more focused on gaming rather than general purpose as
Yeah,
far as
exactly.
compiler is concerned?
Yeah, you have to be familiar with the GCC compiler. Uh, how to optimize your code using different flags, specific optimization flags, and uh, yeah, normally you have to be aware certain compilers maybe not gonna expose all the features available in the CPU, like fast math library and all like SF. What is all the specific? So there are metrics calculations modules. So if these certain things, whether uh, every game has a physics calculation, all this stuff, if they are not optimized for the a specific CPU, then they're gonna the whole entire game is gonna run slow. So
Interesting. Yeah. So that's it. So basically, like I said, I'm not a game developer. I don't really the most that I've used a compiler is maybe modifying a module and recompiling it to use for a specific part of my system or peripheral, right? So I'm not really into all that. But you're saying but you're saying that you can optimize your if you're targeting Linux, you can optimize it by using specific flags during the compile process.
yeah, 100%. Like if you use Intel compiler instead of GCC, certain programs like whether it's a math program, matrix calculation is going to run faster. And also you can optimize the size of the executable as well. If the size is too big, it's going to take up a lot of memory and a stack in the CPU, and it's going to run slow. So if you optimize your executable file for size and um, different CPU flags, it's going to run faster.
So if you're not develop, if you're not working on some AAA title for some giant corporation that makes video games, and you're just an independent developer, you're maybe making a smaller game. Is it going to make a big performance difference depending on how you compile that game? Like if you don't really take the time to look into all the different options and flags or how you're targeting your executable, is it really going to make a big difference if it's a really simple game?
It's not going to make a big difference until you find the bottleneck. Like suppose it's really unpredictable because if you don't understand the whole stack, how they work with each other, like you have a graphics stack, and then you have kernel, and you have a process scheduler, um, and then you have all this stuff. You have to find a bottleneck where the delay is and which process of which thread is delaying the entire cycle of your game, right? So if you know there is not, it's not. I think in most situations you don't have to worry about the flags. You can just apply the optimization flag, one single flag, and it would be superb.
Interesting.
Unless, but in oftentimes because you're dealing with Linux, there will be because you have different options available, especially for the graphics stack. It's not like Windows where the vendors is constantly uh, pushing for the optimized driver, and specifically they're releasing fixes for different games. But nowadays, I think NVIDIA is doing the same for Linux. They're also AMD fixing their driver specifically targeting for specific games. Just like in Windows, mm,
Yeah.
certain effects. If you know certain effects is running slow, whether the CPU is the bottleneck or the GPU is the bottleneck. If CPU is not the bottleneck, then yeah, you don't have to worry about the compiler optimization.
Well, something else you had mentioned because when we were emailing is publishing a game. So like, let's say that you are developing or beginning to develop, or you're ready to complete a game, and you're looking for a place or a way to publish that game for Linux. What kind of options are out there for someone who is a game developer, specifically on a Linux, targeting a Linux platform?
Now you have many platforms. You have a Steam, which is pretty good, but I don't know how much they give you money,
Right.
how much it's back publishing in that store, in that, and then you have good old games, and I think you have Humble Bundle as well, and a couple more which are pretty much Linux friendly and cross-platform friendly. So if you release for Linux, it's pretty much you can easily release for all three platforms: Mac, Linux, and Windows.
Do you remember the Ubuntu store? Did you ever use the Ubuntu store?
I remember that, but I think it's not very popular.
No, no, it was. I actually bought some games on there. They had some ports. I think it was like Steel Storm, and they had a couple other ones that I actually bought on their store. And then their store went away, and I'm wondering, like,
Yeah,
hey, I paid for those games. I want, and I couldn't use them anymore. I guess I don't know. I was wondering if you remembered the Ubuntu store.
I remember. Yeah, exactly. I think they did partner with the Humble Store when they come up, and then some of the games you bought Humble Store actually can bring them over to your Ubuntu store, right?
Oh yeah, I don't know. I wasn't aware. Well,
I
doesn't
did.
Elementary OS don't they have a store as well?
I haven't tried it. I haven't tried Elementary OS. I'm not sure
Yeah, I was thinking
whether.
I was thinking that they had a store. I don't think it was like the Ubuntu store model. I believe it's like pay. It's kind of like if you find a piece of software that you really like, I think you can pay the price that you decide. Like, so if you think it's worth 50 or you think it's worth 10, I think that was their store model. I'm not really sure. I don't use Elementary OS either, but I do believe they have a store where it's
Yeah,
it's kind of like pay what you want kind of a deal.
right.
Yeah.
Is it Elementary store? So I think there's so many few dress stores we're talking about. They have paid software like a store. Ubuntu tried to do something like that, but I think they didn't. They didn't get didn't see the light. I mean, they tried it, but it didn't go that well.
Yeah. No,
And
it died.
uh, they tried Ubuntu phone or something. They crowdfunded this mobile. They tried to, and then it didn't go so well as well. Ubuntu phone.
Yeah.
You remember a couple of years back.
So, I just had a question. If somebody is wanting to get into developing games for Linux, what would be your recommendation for a starting point? Like, how would you help them to get started to do that?
First, you have to understand the C file structure. Linux file structure. Like I was talking about shared library file, where how to compile a shared library and how to debug a C program. At the end of the day, you have to understand C. If you don't understand C, because if you're making game, you're gonna face problems. Your program is not gonna always 100% run smoothly. So you have to, if you know C and if you know how to debug your C and C++ program, then you're gonna overcome the problems. Otherwise, you're gonna get stuck and get frustrated and eventually give up. So first of all, you have to understand how to debug a C or C++ program in Linux, and then um, once you know that, then you have to understand how to compile or create link shared library files in Linux, and then you can use game engines like Unreal engines, Unity engines. There are many tons of different engines, indie engines available now on Linux, like Godot. You can use all of these engines, and it'll be easy for you. And then another thing is Linux file permission. How to set a simple file and permissions of file permissions for Linux files, because sometimes there's the simple thing like picking the executable option for a file can make you frustrated, right? If you don't know.
Yeah.
And then
Permissions.
one thing,
Sorry.
permissions is important for Linux here, because if you don't give it a good permission, like you use a different user, or if you say if you're distributing a game as a root user, right? And no one is gonna be able to open your folder because it's a root user.
Right. Yeah.
It has to be a standard user. And I'd say, yeah, that's all. This very Linux specific. The other things, just like in Windows, you have game engines, you have game creation, content creation suites, all of them. Maya, Blender, maybe 3D Studio Max. You can't use 3D Studio Max, unfortunately. But there are other alternatives you could use for creating your content.
So
Um,
can you kind of break down the parts of a game? Because they're like you're talking about like Blender and such. That'd be for like making your game assets, like your graphics and things like that. And then you've got your game engine. So like, what are the different parts that kind of go into a game?
Essentially, you have to decide whether you're gonna use someone else's game engine, or you're gonna create a game engine of your own. A game engine is the core, is the heart of a game, right? Uh, so depending on of the game mechanics of game physics you're gonna have in your game, you have to choose a particular game engine, or you have to choose a particular game physics library. So if you then you can go. So basically, you have a game engine. Game engine has different parts, right? It has a graphics department, graphics module, sound module, input handling, like basic things, all the basic things. So if you're using one off-the-shelf game engine like Unity or Unreal, then you don't have to worry about a lot of the things, building this thing using Linux libraries like Pulse Audio library or input libraries. So you can forget about this stuff. But if you're not using a game engine, then you're building your own game engine. Then you have to know a little bit more. You have to go dig deeper. Like you have to know about SDL, which is like a very fundamental graphics and input library. Very basic. It doesn't. Then you have to know about Opengl. You have to know about Vulkan. So if you're using a game engine, then you can forget about Opengl. You can forget about Vulkan. You can forget about all the low-level stuff, sound library, input library inside Linux. So game engine will take care of everything. Once you have game engine working and running, then you can use content creation tools to create your content for your game, right? You could use Blender, you could use Maya. Then for asset creation, there are different tools available. You can, for animation, if it's a 3D animation, you can do rigging tools. You can do the same thing in Blender. There are specific tools available for rigging or animation. You could choose those. And if you're doing just photo editing, like texture, uh, in-game texture, you have to use photo editing, image editing tools like GIMP, Adobe Photoshop. But there's no Photoshop in Linux, so you have to know the alternative. And then sound making, I mean, nowadays there are lots of different. Mm, it's not a big deal. Software is available. So you have game engine, you have game assets. You have to create your assets with using different tools, and then the missing last part is the scripting, right? Scripting is how you put the story inside the game. Once you have engine and you have asset, they are lifeless, right? Unless you bind these two together with the scripting. So you write your script like you're writing the level, each level in the game using a scripting. Normally, each game engine has their own scripting language, so you can write your game in the scripting language. But you can choose to have your own scripting language inside the game so that you can have a better mechanism. So you have to just learn how to integrate your game scripting into your game engine, and then uh, in, so fundamentally, if you're using game engine, you you're getting rid of all the hard part, low level stuff. It's solving a lot of the problems. It's solving your scripting, solving all the low level stuff, and then the remaining is the asset creation to uh, suits, different suits.
Yeah.
That's all.
That sounds like really involved when you brought up all the different parts of what the game engine handles as far as like input and processing all that. It's like a whole lot of stuff going on there: sound, video, input controls, and all that stuff. And I would imagine you'd have to take into consideration quite a few things, like when you're actually developing a game engine for that, and like what to utilize on the system.
Takes years and years, just like wine project to make a game engine. I mean, depending on how complex your engine is, like a game engine like Unreal or Unity, they are they're like an operating system by themselves, like big, huge. They support the latest Opengl version, latest Vulkan version, all the features provided by each graphics APIs, and then 3D sound, like you name it, they provide all the things, bells and whistles. You can use that can be used to utilize your hardware, 3D sound, and 3D graphics.
And that sounds like a good idea. Actually, you said they're like an operating system. I want to run Quake OS on my machine. It'd be pretty rad. A gaming operating system that's actually just a gaming engine. I don't. It wouldn't do much, but it'd be cool.
Game engine,
I'm
actually,
kidding. By the way.
yeah, a
Well,
game engine
yeah.
is, yeah.
No, go ahead.
Sorry,
No, we can,
no,
I keep talking when you're going to talk. I feel bad. I'm sorry. Um,
sorry,
no,
was
go
bad.
ahead. Hey, are there any other as far as like I didn't ask a whole lot of questions, but are there any other topics that I haven't mentioned that you were wanting to talk about when it comes to game development that we haven't really covered?
Yeah, one thing I think this is a very strong point for Linux. Uh, this point actually differentiates Linux from other platforms. Um, we haven't talked about Linux graphics stack. We haven't gone very deep into this. But if you coming from Windows or Mac, it's completely different from what we have on the Linux in terms of graphics. Right? Why is different? And this is actually quite beneficial or a good advantage for Linux, I would say, because on Linux we have open source and also closed source graphics stack. What do I mean by open source? We have open source Mesa 3D, which is the entire graphics stack is open source, whether it is Vulkan, OpenGL, everything is open source. And then you have NVIDIA proprietary blob, right? Which is just like in Windows or Mac. But in Windows, you don't have anything like open source Mesa 3D, right? You don't have any accelerated graphics which is open source on Windows. So if your game is suffering from some performance bug or anything has to do with the driver, if you're on Linux, you can easily fix it by yourself. Yeah, because it's open source. You can use a different graphics card profiler tool provided by AMD, and driver profiling tool provided by AMD or NVIDIA to figure out which part of the driver is causing the delay or slowdown in your game. Then you can go into that particular line in your driver, because it's open source. As a game developer, you can understand or go into that particular line, and you can fix it, or you can add hacks or any hard code there to improve your game performance and see what can you do to improve your game performance. And that's what Valve did when they first released Left 4 Dead 4 for Linux native version. It is actually outperformed Windows version, where they said Windows version was performing only 150. I can't remember on the top of my head. Linux way ahead. One of the reason is what they did Valve is they did this kind of a stuff there, because Linux graphics stuff is completely mess. If you're talking about AMD and Intel graphics card, is completely open source in Linux on Linux, so you can improve the driver as well as you can improve your game in a very efficient manner, Unlike in Windows, you can't do that. You just have to rely on the vendor to come up with a fix or something, and it takes time.
Very interesting. Yeah. Well, I feel like we've just kind of scratched the surface here on Linux game development, but I think I'm about ready to wrap it up on my end of things. And thank you so much for being here again, Imam. It's been great.
Oh, much. Yeah, it's nice talking to you.
If you enjoyed this episode, you can join me on Locals at LibreQuest.locals.com, where I'll be posting exclusive interviews, some of my music, and other things. And we can talk about whatever you want to talk about as well. For other ways to support me, you can visit LibreQuest.org. That's LibreQuest.org. And thank you for being a listener. Until next time, I'm Matt, and this is LibreQuest.